Hi, let's look at how we can come up with the inverse of a 3 by 3 matrix. Okay, um, so we are given this matrix here in terms of A. Okay, so to simplify everything here that we are going to do, the formula that we use to find the inverse of a 3 by 3 matrix, but of course this one is in terms of A. We are going to say A inverse is just going to be equals to 1. Okay, 1 over 1 over the determinant. Okay, um, that would be 1 over the determinant of A. So determinant of A multiplied by what? The adjoint of A. So the what we really need to find right now is just the determinant, and we also need to find what? The adjoint. I'll explain a little bit about the adjoint when we start finding the adjoint itself, but of course the easiest thing that we can first of all find is the determinant. Okay, but of course, one thing that you have to keep in mind is the signs of a matrix. So for the signs of a matrix, this is positive, that's negative, and that's positive there. But if you put all the signs together of a 3 by 3 matrix, here's how they appear. You have a positive, negative, positive, then here you have a negative, positive, negative, then positive, negative, positive there. Okay, so let's go ahead and find the determinant of a 3 by 3 matrix. So but for this part we are going to make a lot of you're going to make use of that when we start finding the adjoint. But for now, since we're just coming up with the determinant, we can use the first row together with these signs that we have here to come up with the determinant of that particular matrix. Here's how we do it. So I'm going to say determinant of A is just going to be equals to, you pick 1 as the coefficient and its sign, which is positive, but I don't need to put it anyway because it's just 1, then multiply by a certain matrix. Then again, you go to the second one, you're going to pick 2 as the coefficient together with the sign which is negative. So this is going to be minus 2 multiplied by some matrix there like that. You pick the last one, or the same negative 1 multiplied by some matrix there like that. Okay, so now which matrices are we going to be putting here? So you observe to say if you pick 1 as the coefficient, you are going to shadow the row that it is in as well as the column. Then you're going to remain with this part here. This turns out to be the matrix that you're going to use, which is 0 1 3 minus 1. Coming to 2, if you cross down this column that is in and the row, you observe to say remain with this part and that part, and that's going to be what? Your matrix that is going to be multiplied by the coefficient 2. So that would be a 1 1 3 minus 1. Then for the last one, if you close this one and this one because of the negative 1, remain with 1 1 0 1. So that would be like a 1 1 0 1. So you just have to find the determinant of this of these 2 by 2 matrices, and I believe you still remember how you come up with the determinant of a 2 by 2 matrix, where you just say the major diagonal minus the minor diagonal. Okay, so this is going to be minus 3. That's just going to give us minus that'd be positive 8, then that would be minus 1. So you observe to say the determinant of that 3 by 3 matrix, which is A, is equals to what? Is equals to 4. So there we have it. So now let's go ahead and come up with the adjoint. So now the question that someone might ask to see is, what is the adjoint of a matrix? Like, how do you define the adjoint of a matrix? So the adjoint of a matrix is just the transpose of the matrix of the cofactors. What does this mean? If as we have this matrix here, a 3 by 3 matrix in terms of A, you're just supposed to find the matrix of its cofactor, or the cofactor matrix of matrix A. Then you transpose that, then that will be your that is going to be your adjoint. So it basically means your adjoint. Okay, your adjoint of A, your adjoint of A is equals to what? The transpose of the cofactor matrix. So from this, just come up with the cofactor matrix, transpose it, then it's obvious now you are going to have your what? Your adjoint. So now let's go ahead and find the cofactor matrix. So to find the cofactor matrix, we're going to have 9 sets of matrices, which when we find their determinant, they are going to give us a 3 by 3 single matrix, and we are going to transpose it, and that will be our adjoint. So let me just write this in advance. So we're going to have the first one here, but of course remember we have to use the signs of a matrix as coefficients. Okay, like that. So now here we are looking for the cofactor matrix. So what you do is that one thing that you also have to indicate is that remember we said we are going to use these as our coefficients. So meaning this one is going to be positive, negative, positive, negative, positive, negative here. Then you have like positive, negative, positive, like that. So now the question is, what values are you going to be replacing there? Okay, so we are still going to get them from matrix A, of course. So how we get them is like this. You're going to first of all start with 1. Okay, what happens that on 1, more like ignore the row that it is in and the column, then whatever that is remaining, use it as a matrix. And it's a similar process that you use when you're finding the determinant. So you're going to have 0 here, 1, 3, minus 1. The only thing that's different here is that I'm not multiplying by 1 here as a coefficient. Even the 2 here, I'll not use it as a coefficient on the second one. Okay, so coming to let me use a different color. So that's going to be 0, 1, 3, minus 1. So if you come to 2, this one closes and that one closes. What do you remain with? You remain with this part and that part. Okay, so that gives you 1, 1, 3, minus 1. Okay, then the last one, I mean the one on the other side, um, you're going to get a 1, 1, 0, 1, because when you close this one and that one, you remain with that one. Okay, so come to this one here. This one goes, that one goes, remain with this part and that part. And it's a very simple step-by-step procedure. Okay, you just have to be patient. The next one, if you close down 0 like this one and that one, you're going to remain with um, the 1, 1, minus 1, minus 1. And I'm not really going to bore you going through each and every one of them. So if you patiently do for 3, 1, 1, and minus 1, what you're going to end up with here is going to be like 1, 1, 2, 1. Okay, then down here you're going to have a 2, 0, minus 1, 3. Then you go to you're going to have a 1, 1, 1, minus 1, then 3 there. Then the last one is going to be 1, 1, 2, 0, which is wait a minute, which is this part here. Okay, so now you have to come up with the determinant of each of them. Okay, the determinant of each of them. So you find the determinant for this one, you place here, here, there. You just find for all of them, then you observe to say you have another 3 by 3 matrix, that is your cofactor matrix. Then you transpose it. So when you go ahead and find, you're going to have that the determinant for the first one is 3. This one is going to be 4, 1 here. Then that will be 1, 0. Here you're going to have positive 1 here. Okay, so here you're going to have 1. Then here you're going to have like a 1, a 1, 0, 1. Then this is going to be 6 minus 4 minus 2. So that is the cofactor matrix that we are looking for there. So now we need to come up with a what? With a transpose. I mean, yeah, the transpose of the same matrix. So remember to say the transpose of C, or the transpose of the cofactor matrix, is equals to what? The adjoint of A, which in turn is going to be equals to. So to transpose a matrix, let's remind ourselves, the first row becomes the first column, the second row becomes the second column, the third row becomes the third column. So here you're going to have minus 3, then 4, 1, then you have like 1, 0, 1, you have 6 minus 4 minus 2, like that. Okay, there we have it. So now we can go ahead and find the inverse of A. So you observe to say the inverse of A here, we said it's equals to 1 over the determinant 1 over the determinant, which is 4, multiplied by uh, that one there, which is minus 3, then 4, 1, 1, 0, 1, 6, minus 4, minus 2 here. So you observe to say this one here, we can say the inverse of a is equals to this is going to be minus 3 over 4. This will be 1 over 4. This is going to be 2 over 3 when you simplify it, because this is going to be more like um, it's going to be more like 6 over 4. In fact, that would be 3 over 2, not 2 over 3, because 2 into 6 is going to be 3, then over 2 there, like that. Okay, then the other one is going to be 1 here. When you say 1 over 4 by 1, I mean 1 over 4 by 4, so this will still remain 0, that would be negative 1. So here you're going to have 1 over 4, another 1 over 4. Here you're going to have negative 1 over 1 over 2, and that right there is the inverse of matrix A. So one thing that you can take away from this lesson is you just have to remember how to find your determinant, as well as know how to find your your adjoint. Then your work is going to be much easier. So that's all in this video. Thank you very much for watching.